Dear students, under the topic vector differentiation, in this video lecture we are going to learn about curl of a vector point function. If the vector v is given by v1i vector plus v2j vector plus v3k vector, which is a vector point function, then the vector function nibla cross product with v vector, which is given by the determinant value of I, j, k, and the components of ijk vector in del vector, which is dou by dou x, dou by dou y, and dou by dou z, and the components of ij and k vector from v vector, which is v1, v2, v3. So this is called the curl of the vector point function v, which is also known as rotation of v. So remember, the curl of a vector point function is given by the cross product between nibla, that is the gradient function, the operator, and the vector v vector. We have already seen what is the divergence of a vector point function. The dot product between nibla and v vector gives us the divergence, whereas curl is the cross product between nibla and v vector, which is given by the determinant of this value. So we have to calculate the determinant of this, and we have to find the curl of the vector point function v. We have few remarks to be remembered. That is, the curl measures the tendency to rotate about a point in a vector field, and also it maps the vector fields to pseudo vector fields, that is the imaginary. It may not exist, but it may or may not exist, but so it maps the vector fields to vector fields. If a vector is a constant, then the cross product between nebula and a vector will be equal to 0 vector, and curl of a vector field is a bisector field, and it is denoted by curl of v or rotation of v, which can also be expressed as nebula cross v vector. So let us solve problems under this topic now. So here we have the first problem under this topic, that is to find the curl of the vector point function f vector in the following cases. So there are two subdivisions. I have written the first subdivision here, and following this problem we will solve the second subdivision also. Now we have to find the curl of this vector point function for the vector given by x square y I vector plus y square z j vector plus z square x k vector. We know that the curl of a vector point function v vector is given by the determinant value this. So now here v1, v2, v3 is the components of I, j and k in the given vector. So this will be considered as v1, and this will be considered as v2, and this will be considered as v3. So let us take and substitute these in this formula, that is nebula cross. Here we have been given as f vector. Instead of v we have f vector. So nebula cross f vector will be equal to, so we will take and write nebula cross f vector will be equal to the determinant value of, first we should write I, j and k, and then we know that we have to write dou by dou x, dou by dou y, and dou by dou z. And after this, first v1 we have to write. So what is v1 here? It is x squared y. And what is v2? It is y square z. And what is v3? It is z square x. Now we have to find the determinant of this value in order to find the curl of the vector point function f vector. So the determinant of this will be, so we have nebula cross f vector to be equal to, so what is the first component here? It is I vector. So I vector multiplied with, so since we are choosing I vector, we have to block the corresponding row and the column. So whatever is left out, that we have to take and write in the determinant, that is dou by dou y of this. So after that minus this. So let us write that. So it will be dou by dou y of z square x minus dou by dou z of y square z. So the first component is done. For the second component, we should take with a negative sign as per the concept of determinant. So here we have j. So it will be minus j vector multiplied with. Now since we are taking j vector, we have to block the corresponding row and the column. So if we block it, what do we have? We have dou by dou x multiplied with z square x minus dou by dou z multiplied with x square y. So let us take and write that. So it will be dou by dou x of z square x minus dou by dou z of x square y. So now this is done. After this we have to move on to the next component, which is the kth component. So here you will have plus. So plus k vector multiplied with. Now since we are choosing k vector, we have to block the corresponding row and the column. So if we block it in this manner, so what we will have, we are left out with, we have dou by dou x of this, that is y square z minus dou by dou y of x square y. So that we have to write. So we will write that. So dou by dou x of y square z minus dou by dou y of x square y. So now, so nebula cross f vector will be equal to I vector multiplied with. Now what is dou by dou y of z square x? We do not have y over here. So definitely this will be treated as constant, and so it will become 0 minus dou by dou z of y square z. So we have z here. The differentiation of z is 1. Y square will be treated as constant, and so you will get y square over here minus j vector multiplied with dou by dou x of z square x. So the differentiation of x partial with respect to x is 1. So z square will be treated as constant, so you will get it as it is, minus dou by dou z of x square y. We do not have z term over here, so it will become 0. So 0, and then plus k vector multiplied with dou by dou x of y square z. We do not have an x term over here, so it will become 0 minus dou by dou y of x square y. So the differentiation of y is 1, and x square will be treated as constant, so you get it as it is. So next will be, so this will be minus y square and I vector, and then minus z square j vector, and here we have a negative sign, so minus x square k vector. Since we have minus in all the term, we can take it common, and nebula cross f vector will be equal to negative y square I vector plus z square j vector plus x square k vector. So this is the solution. So this is how we have to find the curl of a given vector point function. So we will do another subdivision to understand this concept more better. So now let us find the curl of the given vector point function f vector, which is given here. So we have to find curl. So nebula cross f vector will be equal to determinant of, first we should write I vector, j vector and k vector, and then dou by dou x, dou by dou y, and dou by dou z. And what about here v1? What is v1? The ith component v1 is xyz. Next is v2. v2 is the jth component, which is xyz square, and the kth component v3. So this is v3, which is x square yz. So now we have to find the determinant of this value. So now how to find the determinant? So this will be equal to I vector multiplied with, so as I told you, we have to block this row, column, and this row, and so this multiplied with this, so dou by dou y of x square yz minus this multiplied with this, so dou by dou z of xyz square. And then the jth component we have to take, and so it should be negative j vector, because the second term when we choose we have to take with a negative sign, and block this row column and this row. So it will be dou by dou x of this one, so x square yz, minus dou by dou z of this one, x y z. The next will be kth component, so that is plus k vector multiplied with, so we have to block this column and block this row as well. So it is this into this, so dou by dou x of x y z square minus this into this, so dou by dou y of x y z. So what is the partial differentiation of this term? That is, this will be equal to I vector multiplied with partial differentiation of x square yz with respect to y. So x square z will be constants. Differentiation of y is 1. So you get x square z minus, what is partial differentiation of this with respect to z? This alone we have to differentiate. So it will be 2z. So 2xy will come as it is z, and then minus j vector multiplied with partial differentiation of this term with respect to x is 2x, so 2xyz, and then minus dou by dou z of xyz. The differentiation of z is 1, so you will get xy alone here, and then plus k vector multiplied with partial differentiation of this with respect to x. Differentiation of x is 1, so you get yz square minus partial differentiation of this with respect to y. So the differentiation of y is 1, so the remaining will be x and z. So x and z are will be treated as constants, so they come as it is. So we will write it in a proper as a vector, that is x square z minus 2xyz I vector minus 2xyz minus xy j vector plus yz square minus xz k vector. We can leave the answer as it is, or we can also even take the common terms and we can write it. For example, here z is x and z are common, here x and y are common, and here only z is common, so you can take and write it also. So I hope you would have understood how to find the curl of a given vector point function f vector. In our next video, we will find the curl of a function at some particular points. So let us learn how to find the curl of a function, vector point function, at a given point. So we will learn about it in our next video. Thank you.